Hello. We're going to be doing a video today over the linear characteristics of domain, range, intercepts, zeros, increase, decrease, positive, negative, and end behavior. It's a lot on one video, but I hope this helps you when you're doing your assignment at home or just to look at later. All right, this is the word problem that we're going to be using. This is the real world example. Sharon wants to find out how much money she will have in her savings account after 10 weeks. She has $20 now and will earn $10 an hour babysitting for the next 10 weeks. If she works 15 hours a week, how much money will she have after 10 weeks? Now, X is your number of weeks, F of X is your Y, so when we write this rule, remember we start with what we have. This is actually our beginning amount. So our beginning amount is $20. That's where 20 comes in, plus $10 an hour, and then 15 hours each week. So that 10 times 15, that's what that is, $10 an hour for 15 hours. And then X is your number of weeks, which gives us 20 plus 150X. So, and then we go on and we solve that by writing a table. And so for 0 weeks, we plug 0 in, we get 20. When we plug 1 in, 150 times 1 is 150 plus 20 is 170. When we plug 2 in, that's 320. Then when we plug 4 in, you can see the progression of the table. I don't need to explain that. We'll go over that a little bit better in class, but here is the table all the way down to 10 weeks, and that's what it asks for. How much money will she have in 10 weeks? That just gives our real world application problem an ending. And so we could have made that be anything we wanted it to be. All right, now we're going to graph that function. So this is the number of weeks and this is the money. So at 0 weeks it's $20, and all I did was take that table and plot the points on that table. And so all of these are those points that came from the table. So this is the function, and it is going up. It is an increasing function. Okay, now we are going to answer these things in relationship to that graph and in relationship to the function that we just got through doing. So the domain is all possible X values, remember. So if I go back and I look, my X values go all the way from 0 weeks to 10 weeks, because the question asks you how much money would she have at the end of 10 weeks. So we made our domain 0 to 10, and we put brackets because 0 is part of it, and so is 10. They're actually part of the equation, so we put that in. Our range is going to be the Y values that we have, and if you want to see those are in our table. Here's our X values, here's our Y values, and they go all the way from 20 to $1,520. So that's our range. So that's how we're getting that. There is no x-intercept. If you look back at this graph, there is no place where this graph is going across the x-axis. And if you look back at the table, if it were touching the x-axis at all, then we would have a 0 somewhere on our y, and we do not. This is x, this is y, there is no 0. So therefore, this function has no x-intercept. It does, however, have a y-intercept. You see here where x is 0, y is 20. That's how we recognize our y-intercept. On our y-intercept, for our y-intercept, the x will be 0. Now, if we interpret that in terms of the real-world application that we have, at 0 weeks, there was $20 in her checking account or savings account. Right now, I can't remember which word the equation used, but there is no x-intercept. So since there is no x-intercept, there's no 0 to the function. Remember, the 0 of the function is the x coordinate of where the x-intercept is. Okay, now, is this function increasing or decreasing? Go back, look at the table, look at the graph. See, the graph is going up. It is increasing from left to right. You see this right here. If you look at the table all the values are increasing from left to right. You see, anyway, they're going from 20 to 15, 20. They are all increasing. The y is increasing. So remember, increasing refers to the y. Where that is happening refers to the x. And that is happening all the way from 0 to 20. The entire function is increasing. Where is my function positive at? Well, again, we're talking about the y value. So if you go back to the table and you look at your table or you look at your graph, all of this is above the x-axis, this being the x-axis. Every point is above the x-axis. So the whole entire graph is positive, and that would be from 0 to 10. So it is positive all the way from 0 to 10. It is not negative. Nowhere on that graph does it drop below the x-axis. End behavior. All right, let's look at our table one more time, and you can see your end behavior on the table. As x approaches 0, f of x or y approaches 20. As x approaches 10, f of x or y approaches 1520. And that's how you label that. You just read the ends. That's it. So our end behavior is just reading this side and this side, or the top and the bottom of the table, or reading the left and the right, the leftmost point and the rightmost point on the graph. That's all that is. All right, now let's look at it as far as theory goes, not the real world. Let's just look at a line that keeps going continuously across the graph. When we look at a line, remember how I taught you the other day to label your infinities. I taught you to do this. I taught you to say, all right, this is positive infinity. If I continuously go this way, it's negative infinity. If I continuously go up, that's positive. If I continuously go down, that's negative. So if we're looking at our domain, remember that's all possible x values. So my lowest x value that I have on the graph is right here at negative infinity, and my largest one's infinity. So that's going to be from negative infinity to infinity. If I look at my range, that's going to be, again, my lowest y value to my highest possible y value. So that's from negative infinity to infinity. My x-intercept, that's where the graph crosses the x-axis. It crosses it right here at this point. That is 3.5 and 0. And remember, the 0 of the function is the x-coordinate of the x-intercept, which is right here, 3.5. The y-intercept is where the graph crosses the y-axis at. That's 0, 3. This function is decreasing. If I put a rod right here, it is going down continuously, the entire function. So when I say decrease, I'm talking about y values. The y values decrease. If I were to label these points, they would be decreasing. If you look at the y's, they go down. And it is decreasing all the way from negative infinity to infinity. Where is this graph positive? Well, this graph is going to be positive at all points. This up here is where y is positive. These quadrants here is where y is negative. So if I read the graph, the x values, where it's positive from negative infinity all the way to 3.5. Then from 3.5 to infinity, y becomes negative. So when I do that, when I'm looking at those things, it is positive from negative infinity to 3.5 and negative from 3.5 to infinity. And when I use the word positive and the word negative, remember that describes y. Where that happens or occurs at on the graph is described by x. Okay, and remember end behavior, all you're doing with end behavior is just reading the ends of your graph. So as x approaches negative infinity, what is y? It's infinity. As x approaches infinity, what is y? It's negative infinity. Okay, one more. Okay, we have this function here, same thing, but this function is increasing instead of decreasing. So if I put my rock here, this one's going up, it's increasing all the way from negative infinity to infinity. Now my domain and range on any line, unless it has endpoints is going to be negative infinity to infinity. So when there are arrows, that's what it's going to always be. My x-intercept's negative 2, 0. That makes my 0, negative 2. My y-intercept is 0, 4. And I've already gone over increase. All right, now look. Again, where is this graph positive? Remember, when we say the word positive, we are talking about y. Y is positive up here and here, which is the region from negative 2 all the way to infinity. And then it is negative down here, which is from negative infinity all the way to negative 2. So negative infinity to negative 2. And again, you're just reading the ends of the graph for end behavior. So all I have to do is read the ends. As x approaches negative infinity, what is y? It's negative infinity. As x approaches infinity, what is y? It is infinity. Thank you.